Hi, thanks for joining me. Today I'm going to be looking to solve this problem here. I'm looking for x, y being positive integers satisfying this equation here. 493 plus x squared equals 2 to the y. If you want to have a go at this problem, pause the video now, and in just a second I'm going to go over a solution. Okay, so now look at the right hand side. We've got 2 to the power of y, and y is a positive integer. So that means that the right hand side is either 2, 4, 8, 16, and so on. So that means that the right hand side in particular is even. Okay, so that means that the left hand side must also be even because the left hand side equals the right hand side. Well, 493 is odd, so we have an odd number plus x squared gives us an even number. Well, that must mean that x squared is odd because odd plus odd is even, and odd plus even is not odd. Odd plus even is odd, which is not even. So x squared must be odd. Okay, well that also means that x must be odd. Okay, so that we have x can be written in the form 2k minus 1, where k is some positive integer. Right, well let's just put this back into this equation here. So we get 493 plus 2k minus 1 all squared equals 2 to the power of y. Well, if we expand this out, we can write this as 493 plus 4k squared minus 4k plus 1 equals 2 to the power of y. Now I'm going to bring this 1 to this 493 to make 494, and then I'm going to factor this 4k squared minus 4k. So I get 494 plus 4k times k minus 1, and that equals 2 to the power of y. Now, if we look back at our original equation here, we see that the left-hand side, because x squared is going to be a positive integer, 493 plus x squared is going to be at least 494. Okay, because obviously x is at least 1, or x squared is at least 1. 490. So we have the left-hand side, which is at least 494, and that equals a power of 2. So that means it must be a power of 2, which is at least 494. Well, now if we look at the powers of 2, 2 to the 8, well that's 256. 2 to the 9, that's 512, which is bigger than 494. So that means that because our left-hand side equals the right-hand side, they're both powers of 2, and the right-hand side is 2 to the y, which is at least 494, but because it's a power of 2, it must then be at least 512, which means that y is going to be at least 9. So we have that y is at least 9. So going back to this equation which we've derived here, we know that y is at least 9, but in particular it means that y is at least 3. So that means that 2 to the y is going to be divisible by 2 cubed, i.e. 8. Okay, so 2 to the y, remember, well, we can write this as 2 cubed times 2 to the y minus 3. Now we know that y is bigger than or equal to 9, so that means that y minus 3 is going to be a non-negative integer, or actually it's going to be a positive integer, which means we've got 2 to the power of a positive integer. There we go. 2 to the power of a positive integer, which is a positive integer. So this whole thing is a positive integer times 2 cubed. So this is, if I call this thing here lambda, this I can write as 2 cubed times lambda, which is just 8 lambda. So I get 494 plus 4k times k minus 1 equals 8 lambda. Now, I'm going to bring this 4k, k minus 1 to the other side. So I get 494 equals 8 lambda minus 4k times k minus 1. I'm just going to rub this off and put it here. So 8 lambda minus 4k times k minus 1 equals 494. Okay? Oops. So we have this equation here. Now here's the trick to this, is if we look at the left hand side, it's always going to be divisible by 8, no matter what lambda is and no matter what k is. Because we know lambda and k are positive integers, if we look at this thing here is always divisible by 8 because of the 8 out the front there. And this thing here, if k is odd, then that means that k minus 1 is even. So we've got an even number times an odd number, so that thing there is going to be even. And obviously we've got the 4 out front, so we've got 4 times an even number, so that's always going to be a multiple of 8. So if k is odd, then this thing here is a multiple of 8. But obviously we can apply the same argument if k is even, because if k is even, then k is there is even, and then k minus 1 is odd. So we've got even times odd, which is an even number. Then again we've got the 4. So that's always going to be a multiple of 8. So we've got a multiple of 8 minus a multiple of 8. That's always going to be a multiple of 8. So we can write the left-hand side as 8 times mu, where mu is an integer. But the right-hand side is 494. Now this is 61 times 8 plus 6. 61 times 8 is 488. Then plus 6 is makes it 494. If I bring the 61 times 8 to this side here, I get 8 times mu minus 61 equals 6. And here's where we arrive at the contradiction, because mu is an integer, 61 is an integer, so mu minus 61 is an integer. On the left-hand side I've got 8 times an integer, so the left-hand side is a multiple of 8, but the right-hand side is 6. So I've got 6 equals a multiple of 8. But obviously that is a contradiction, because you can't divide 6 by 8. So we've arrived at a contradiction, which means that this equation here actually has no solutions in the positive numbers. So I guess in some ways it was perhaps a bit of a trick question, but there are no integer solutions, and this argument proves that. I hope you've enjoyed this video, and that's it for now. Have a great day. See you.